Hello, my name is Anna, and today we are going to discuss some issues about Redis. What is Redis? Redis is a remote dictionary server, an open source in-memory data structure store. It was initially developed by Salvatore Sanfilippo, now it's sponsored by Redis Labs, and there are lots of people who have contributed to this project. So, Redis is known as NoSQL database and key value store. And key value store, the essence of it is the ability to store some data called a value inside a key. And later you can retrieve this data only if you know the key, the exact key you used to store it. In order to achieve great performance, Redis also uses in-memory data set. That means that you put all your data on RAM. At the same time, you put all your commands in log file. So, I'm sorry. Key features. Redis is developed in NCC and use atomic operations. Initially, it was developed for POSIX systems like Linux, but in case you have Windows, there are no problems. Microsoft now develops and maintains Win64 port for Redis. At the same time, Linux and OS X are the two operating systems that are mainly more tested than others, and they are recommended for deploying this system. There are lots of advantages of using Redis, and one of them is that you can keep a huge amount of data in it, and each entry can be up to 1 gigabyte of data. That means that 512 megabytes for key and 512 megabytes for value. Redis uses data replication and hash. It provides an uninterruptible service due to very good replication. At the same time, it has clients for all the most popular programming languages. In the next slide, you will see the list of them. So Redis offers a pub/sub system, messaging system, and it can provide inserting huge amounts of data into the cache using mass insertion function. Redis can be used for Internet of Things and installed on Raspberry Pi and IRM. That are two officially supported devices. That is possible because the memory footprint of Redis is very small. So Redis supports transactions, and that means that commands can be executed as a queue instead of executing one at a time. Here is a list of the most popular languages that have libraries of Redis. So, Redis is not a plain key value store, it's actually a data structure server, and that means that in traditional key value stores, you put string for a key and string for value, but in Redis you can use more complex structures for this. So, Redis keys. Redis keys are binary safe, and that means that you can use any binary sequence as a key, from simple string to content of JPEG file, and doesn't matter. And empty string is a valid key, and keys are limited by the size of 512 megabytes, as I have said, so I'm sorry. Here is another point. Redis keys can be told to have time to live. That means that they should be destroyed after a period of time, and you can do this, you can accomplish this function using expire and TTL commands. So in this example, you can see that we set a resource log, and then we set an expire for it. An expire is 120 seconds. After 7 seconds, we just want to check what is the time to live for this key, and we can see that the time to live is 113 seconds. In case we make TTL command, we ask for TTL command but get -2, that means that this key does not exist anymore. And in case we get -1, that means that there is no time to destroy this key. That means that it will exist forever. In case you just make set once again, your previous expire is updated. So, as I have said, Redis can work not only with strings but with complex data structures, and here they are: binary safe strings, lists, sets, sorted sets, hashes, bit arrays or simply bitmaps, hyperlock locks, and streams from version 5.0. And as I have said, value can be bigger than 512 megabytes. So the type of data you use for your value defines the comments you can use for them. So main comments in Redis have very good documentation, and you can find here 2 links to them, and all the comments are very well described, and there is a tutorial on the website. You can just try it and see what comments are defined for each type of data. So let's have a look. Oh, in case you try to apply the comment that is not suitable for this type of data, you have just put for a value, you'll get an error message. That's evident. So first type of data that can be used is strings. Strings are basic kind of strings, and they're binary safe. That means that you can put any information inside of it, whatever you want. In the first example, we see how a command set, how to set a key for strings. In the second, we see an example how it can be used. So strings can be used as counters, as atomic counters. We should notice that they have atomic comments, like increment of increment family, increment, decrement, increment by, and so on. So next type of data are lists. Lists are simply lists of strings. They are sorted by insertion order. Just you put another one and that appears in the list, and you can put new entries from the tail and from the head, and that has 2 different commands for this: L push and R push. So using L push and trim, you can create a list that contains only last n elements, and you can mainly use it to hold the latest items, whatever they are: social network updates, logs, anything else. And here you can see an example. It's shown in this example that you can put some elements, multiple elements, into a list via a single command. So I haven't mentioned that when you use list, when it is empty, Redis creates lists itself, and when there are no entries in a list is destroyed by Redis itself. And that does not mean that this is suitable only for lists. This is suitable for streams, sets, sorted sets, and hashes too, for complex structures. So next type of data is sets. Sets are an ordered collection of unique strings, and it's possible to add, remove, to test the existence of members in a short time. So Redis supports a number of server-side commands, and you can do unions, intersections, differences of sets in a short time. So it's very good to express relations between different objects. Next type of data are hashes. Hashes are maps between string fields and string values, so they are perfect data type to represent objects. So if you use, for example, objects that have name, surname, age, and so forth, for example, for keeping data of your users, a hash with few fields is stored in the way to take so little place that you can set millions of objects in a small Redis instance. The hashes are used mainly to represent objects and are capable of storing many elements. So here you can see the example of hashes and the command for set and get all information or just part of information. So sorted sets are the sets that have its collection of unique strings, but it has score, and score is used to order sets. This type of data is mainly used to set leaderboards. As far as lists, for example, they have very fast access to the end and to the head and to the tail of the list, but at the same time it's very slowly to get to the middle of the list. At the same time, sorted sets are used just to take two middle elements too, because they are too fast. And using score, you can just reorder them the way you need and just update the information very easy. And that's the most complex type of data probably, but at the same time it shows great performance. And in this type of data you get whatever you want. Elements are ordered. You can use fast existence test, at the same time fast access to elements in the middle. That's what you want. And there are lots of commands used for this type of data. And by the way, you can have a look at the link shown before. So two other types of data are not shown in the slides, but I should tell you something about them. That are bitmaps and hyperlocks. Bitmaps are bit-oriented operations for strings. They are used to provide extreme space savings when you use them to store information. For example, you can just use a single bit to keep the information about your for users receiving newsletters. That means that you can have 4 billion users and use just 512 megabytes of memory to store the information about them. And hyperlock locks are used to count unique things. Nevertheless, they not commonly used in GS. So the next point we should discuss are transactions. Transactions are a queue of commands that can be proceeded once altogether, and that give you two guarantees. All the commands in transaction are serialized and executed sequentially, and that means that no other client can be served in the middle of the execution of transaction. And the second guarantee is either all of the commands are processed, or none of them, and that means that these transactions are atomic. So there are 4 commands to produce transactions. They are multi, exec, discard, and watch. Multi is used to start transaction, exec to execute transaction at all, discard if you want to just flush all the data you need, and the watch is a special command that is used to for so-called check and set behavior of Redis transactions. So here is an example of transaction, and here you can see the replies you get from the system. So when you put multi, it responds you OK. Then you just put comments and it responds you skewed. And then you just put exec, and this is the command to execute the transaction. Then you get the result. The result is an array of data. So array of replies. In case you get error, you will see an error message. And there are 2 types of errors. First of them may take place before exec command, and that the client aborts the operation itself, and after exec command it's generally that server aborts the operation. So there are lots of issues that can be discussed in Redis, but we do not have enough time and data for this, and in case you need more information and you want to know something new, you can visit official site and see a tutorial there. It's a great information source, and actually it's rather interesting to have a look at it. So thank you for your attention and have a good luck studying in Rolling Scope School. I'm great to study with you. Thank you.